Hello, welcome to another module in this massive open online course. So in this module, let us start looking at yet another innovative application of optimization, and this is in the field of big data. And in fact, big data is something that has gathered a significant amount of attention of late because of the tremendous rise in the amount of data that is being generated each day in various websites or various online services that are there, and big data has several applications. Of course, we are not going to look at all possible applications of big data or all possible all possible techniques for big data, but we are going to look at one very specific and a very relevant technique for big data, one that is very popular and very relevant in the current scenario, and that is for the design of what are known as recommender system. So we are looking at, so this is basically an application. You can just treat this as an application or a technique. You can think of this as a technique for big data. And what this is, I am going to describe this more as we go along. Now, what is a recommender system? We need to understand first what is the concept of a recommender system. A recommender system is something that is very simple, that is, it recommends other items. So, recommender system, as the name implies, it recommends other items based on your purchase or viewing history. So, this is based on your purchase or viewing history. Okay. And for example, you might have seen it in several various popular online websites. For instance, if you go to an e-commerce website such as Amazon, you have several product recommendations. For instance, in an e-commerce site, based on your viewing history or the items that you have browsed, or based on even your past purchase history, you have a set of items that are recommended that the website thinks are most suitable, right, or I think would be in your interest or would be of high interest to you, all right. Or YouTube videos, even when you go to a website like a video streaming site like YouTube, when you look at the different videos, or when you are watching current video, the website automatically comes up with a recommendation of other videos that you might find a lot of similarity or that you will be highly interested in. And similarly, music websites, like the Pandora, for instance, is a music website, and then it comes up with a set of music videos or music albums or songs that would be of very high interest to you. And some of these you might not be aware. And the interesting about these is this is very helpful, because some of these things you might not be aware exist. So by coming up with this highly specific set of recommendations, it's a win-win situation both for you, because you cannot browse the infinite number of products on an e-commerce website, and similarly it's also beneficial for the website, because enticing the customers to this possible set of objects that the customer is interested in, they are increasing their business. So it's a win-win situation for everyone. It saves you time, increases the business of the website, and so on. And for this part, this module will be referring in particular to this very interesting book, and in particular the chapter on the book by Professor Mung Chiang titled Network Life 20 Questions and Answers by Princeton University. And the chapter that we are talking about is chapter 4, which is how does Netflix recommend movies. We are going to talk more about this. Netflix is one particular website. So all such systems which basically recommend various options for you, various other products, various movies or videos or products for you to buy, these are known as recommender systems. That is, they are recommending a set of products or objects to you. Okay. Of course, now you cannot come up with arbitrary recommendations. The more pointed or the more specific your recommendations are, for instance in an e-commerce website, you can just recommend an arbitrary set of products, but that is not going to help much. The more specific, in the sense that the more interest the more closely your recommendations match the interest of the consumer, the better your recommender system is, and the better is going to be the efficiency of your website. All right. So the idea is, the goal is to design the best recommender system, which comes with a very specific and a highly interesting set of recommendations. For instance, this is a simple snapshot from one of the e-commerce websites. You have a book that you are interested in buying. All right, this is the book you are interested in, and the website comes up with an alternative set of recommendations. So you look at this, these are your alternative, or these are your set of recommendations, all right, or your recommended items, based on, which is either based on your viewing history, or interestingly also this might be based on the viewing history of someone who has a similar viewing history, or who has an interest that are very similar to yours. So the recommender systems are very interesting. So they look at patterns of different users, their purchase histories, mine these patterns and come up with recommendations based on what other people who had similar interests have purchased or have viewed, and so on. Okay. And for instance, again on another e-commerce website, you are looking at an object, or you are browsing at an object, and these are your recommended set of objects. These are your recommended objects. Okay. And now coming to our original problem, I mean, recommender systems are everywhere, and if you go to any e-commerce website, any video website or so on, recommender systems are everywhere. Okay. One particular interesting application that we are going to talk about is that of Netflix. Netflix is an online DVD rental site. Okay. Started in 1997, and the model of Netflix is that you send DVDs by mail. That is, you send DVDs by mail or regular post, which you can order online. Okay, so DVDs rental, so you can order these, order online, or basically you can request these online and they will be sent by mail to you for a fee, of course. Now, of course, once you send in again, once you watch the DVDs, you send them back, you get a new set of DVDs. All right, that's specific to that particular website. Now, the key innovation here that we are talking about is basically Netflix, the website. It generates personalized movie recommendations for each user based on your past viewing history. So based on the movies that you have already seen. Okay, so you generate movie recommendations for each user, specific to each user, based on movies that you have already seen, okay, or based on your past viewing history. Alright. So what you do for this is basically you collectively mine the viewing patterns of an extremely large number of users, that is users, that is all the movies you have seen and the movies that a large number of users have seen, come up with these, so mine these patterns to extract information, and then based on this mining of this collective data of users and movies, you come up with the specific set of recommendations for a particular user, and for that matter for each user, which is in fact, if you consider this problem by itself, is very fascinating. So it comes up with a set of recommendations, or comes up, in essence, it comes up with a set of ratings for you for the movies which you have never seen. That is in essence what this problem is. So it recommends movies to you based on what it thinks, what Netflix thinks are movies that you are going to rate highly, which means it has to generate a predicted rating for you for a set of movies that you have not seen, and then choose a set of movies based on what Netflix or that website thinks you would rate very highly. So this problem in itself is a very, very interesting problem. Okay, and what is interesting is that Netflix, for instance, this is a simple, if you look at a Netflix website, this is a simple snapshot of Netflix. These are some movie recommendations from Netflix. These are some movie recommendations from Netflix, based on what it thinks that that particular user, and you can see there is a set of movies, all right, based on what it thinks that particular user would. And of course, as I have already said, the more relevant these movies are, or the more interest these movies generate from that particular user, or the more the closer these movies are to that particular user's interest, the better is the recommender system. So, what are the number now? In 2009, Netflix had about 100,000 titles, and in 2013 about 33 million subscribers. Okay, so there's 33 million subscribers, and in 2005 was close to shipping about 1 million DVDs a day. That's a large number. So you can think of that, 1 million a day implies, you can think of the large amount of data that this generates. Implies this is a big data problem. So we are generating a large amount of data, which is basically nothing but your big data problem. So from this large amount of data, how do you mine the patterns? Okay. Now in 2006, Netflix rolled out an interesting challenge. This is termed as the Netflix challenge, okay, to the research community, and it had a huge prize. And what happened in that challenge is it made available 100 million ratings. So 100 million ratings were made available. So you can see that is basically your big data, large amount of data, which is, if you look at 100 million, that is 100 into 10 power 6 equals 10 power 8 ratings, which could fit into a standard memory of a standard desktop. Now of course at that point it had about 480,000 users, and now of course these ratings were about for 480,000, that is roughly half a million users, approximately half a million users for 17,770, that is approximately 20,000 movies. That is, if you look at this, this is 5 into approximately 5 into 10 to the power of 5, that is half a million users, and this is 2 into 10 to the power of 4 movies, which implies approximately number of ratings equals 5 into 10 power 5, number of possible ratings, I will clarify this in a moment, 5 into 10 power 5 into 2 into 10 power 4, which is basically approximately, again this is 10 power 10. So, that approximate number of possible ratings equals 10 to the power of 10. Now, this is the number of possible ratings, but the actual number of ratings is only 10 to the power of 8. Now, the reason for that is very simple, because remember you have half a million users, you have 20,000 movies, but each user has not seen every movie, right. So, each user has probably seen a fraction of the movies, correct. Each user has probably seen 100 and 200 or 200 movies or so on and so forth, okay. So, if you look at all the users and all the movies, the total number of possible ratings is 10 to the power of 10 if each user watches every movie and rates every movie, but that is not possible, alright. So, the total number of possible ratings, total number of actual ratings that are available are only close to 100 million, that is 10 to the power of 8, which means only 1% of the ratings are available, okay. So, which means only a small fraction, and this is the important point. So, only a small fraction of ratings are available, that is 10 to the power of 8, which is 1%. So, 10 to the power of 8 by total possible 10 to the power of 10, if you look at that, that is basically 1%, okay, 1% are available, only 1%, which means what do we have to do? We have to predict the rest of the rating, okay. So, rest of the ratings have to be predicted, and based on these predictions you come up with the movie recommendations for each user. Remember, if each user have seen every movie, then there is no need to come up with a recommendation, right. In e-commerce website, if every person has bought every item, then of course there is no set to come. The challenge is because few people have bought few items, and it is not even that few people have bought the same items, different people have bought different items. So, from this checkered kind of matrix, we have to come up with the ratings and recommendations for each user, okay. So, each movie was rated by approximately 5,000 users, okay. So each movie approximately 5,000 users. And each user rated approximately. So you can see approximately 200 movies. So approximately 200 means 200 divided by 20,000 total number of movies. So this you can see is approximately 1%. So that's where you get the number from. Alright. So each user has seen about a percent of the movie. So 20,000 titles are available. Each user has seen roughly about 100 to 200 movies. Of course, over a long period of time, maybe over 2 years, 3 years, couple of years. So you've seen 200 movies, rated them. Alright. So each user roughly seen 1% of the movie. Each movie, of course, rated by again roughly about 500,000 users. Okay. Now what we have to do is, as I have told you, to develop a program to predict the ratings and provide recommendations to the user. So this is the challenge. This is the Netflix challenge. Or this was the Netflix challenge rather. Alright. So you look at all these ratings that are available and then you come. Now how do you test this? Now if you look at it, this problem looks something like this. So you have a set of movies here, movies 1, 2, 3, 4, 5, 6. Let's, for the sake of this thing, avoid confusion, let's call it movies A, B, C, D, E, F, G, H. So you have movies A, B, C, D, E, F, G, H, and you have users 1, 2, 3, 4, 5, 6. For instance, user 1 has not seen movie A, but he has seen movie B and rated movie B. User 1 has seen movie D, rated movie. User 2 has seen movie A, movie C, movie D, rated. So these are the ratings that are available. Now these ratings, the empty blocks are ratings. So for instance, user 1 has not seen movie 6, not seen. So these ratings are not available. Which implies these ratings have to be predicted. These ratings have to be predicted. And now if you look at this, you treat it like a matrix. For instance, this matrix is nothing but rows and columns. You have these rows are the users, each row corresponds to a user, each column corresponds to user. So now some users have rated some movies, therefore some entries of this matrix are filled. The rest of the entries of this matrix are vacant, and therefore we have to complete. Predicting the ratings means basically we have to complete this matrix. This problem is of fundamental importance in signal processing and various other or big data. This problem is known as a matrix completion problem. This is known as a matrix completion problem. This problem is known as a matrix completion problem. So you have about 480,000 users, that is 500,000 users, correct? In terms of the example that we just seen, or the Netflix problem, you have 500,000 users, 20,000 movies, which means the total size of the matrix, the number of elements in the matrix is 500,000 into 20,000. Okay, so in a Netflix program, size of matrix is this is a matrix of size 5 into 10 power 5, 500,000 times 2 into 10 power 4. Okay, and out of these 10 to the power of 8 entries are filled. It's like a puzzle, implies rest equal to 1%, implies rest 99% have to be completed or filled, and this is basically a matrix completion problem. That is the interesting aspect of this, is a matrix completion problem, and the size of the matrix is humongous, as you can see. It's a huge, and this is because this is a problem big data. The way the contest was organized was very simple. You have 100 million of training set that were made available to the public, and there is a probe set, and the probe set, all right. So the probe set the users can test, because obviously you don't, because one has to of course eventually test what is the performance of the algorithm that is being proposed. So there is a probe set, there is a final quiz set, okay, and these are hidden. Now the quiz set and the test set, these are hidden, and finally the algorithm is tested on the quiz and test set. So these are hidden, and finally these are tested on the hidden test set. To find, different researchers submitted different algorithms. The performance of the algorithms is tested on the quiz sets and the test set, and whichever algorithm performs the best, that is, it gives the recommendations on the test set, correct, which are best or which are closest to remember the ratings that are given by the users, all right. So the performance is tested against actual ratings given by the users, because these are hidden, and that algorithm is obviously best because it is best able to predict the ratings of the different users, okay, all right, and that is it. So that is basically the interesting problem, and this is a very interesting problem, and it's one of the most elegant and one of the most interesting applications of big data, and in fact one of the most powerful applications of big data, as I have already told you, is in the context of this recommender systems, because they are used everywhere. They are used in online websites, video streaming, music websites. They have a very, very big application in e-commerce. In fact, one of the key forces, or you can say one of the key components of any e-commerce website is a recommender system, because the more robust your recommender system is, the more the better your recommendations are, and the more closely your recommender system is able to predict the ratings for different users for the objects which they have not purchased based on their browsing or purchase history, the better is going to be the business of the e-commerce website and the more efficient it's going to be, alright. So this is a very, very important point, a very, very key component or very important application of big data, and convex optimization has a very important role to play this. In fact, optimization has a very important role. So we'll stop here and look at how to handle this problem. How can convex optimization help in addressing this problem? We'll look at that in the next module, alright. Thank you very much. Or basically, how do you use convex optimization to handle this problem of big data? That is what big data, and specifically this problem of matrix completion, which is closely tied to a recommender system, alright. So we'll stop here and start looking at this, exploring this problem in the subsequent modules. Thank you very much.